Welcome to This Explainer. Okay, today we are unpacking an idea so profoundly strange, it's going to force us to question the very fabric of reality, and honestly, our place within it. We're diving into a theory in physics that, when you follow it to its absolute logical conclusion, suggests something terrifying, awe-inspiring, and actually deeply personal about you.
Seriously, think about this for a second. What if you never actually die? And no, I don't mean through some futuristic technological upgrade or leaving a legacy or a religious afterlife. I mean, what if the fundamental mathematics of the universe physically prevent your consciousness from ever experiencing its own end? Just imagine a universe where you miraculously survive every single deadly accident, every close call, every fatal illness. It sounds crazy, right?
Section 1. The Ultimate Survival Test.
All right, picture this. It's the future, and teleportation is just the standard way we travel. The process is super simple. You step into a pod, and every single particle of your body and brain is scanned, mapped, and modeled in a fraction of a second. That data gets beamed to your destination, and boom, you are perfectly reassembled. But imagine one day you step in, and there's a system glitch. During the reconstruction phase, the machine accidentally runs the model twice. So now, suddenly there are two of you at the destination. Two perfect, identical clones. Both of you are picking up exactly from where you left off, with the exact same memories, the same birthmarks, the whole shebang.
But wait, let's make this a whole lot darker. What if instead of both arriving cleanly, one of you arrives completely normal, ready to hit the beach, and the other arrives as a lifeless puddle of flesh and liquid brain matter? Gross, I know, but think about it. All the particles are there, but the life is just gone. So did you die? Did you live? Which one is the real you? Because from the perspective of the survivor, everything went exactly as it should. It's a terrifying contrast, but it really highlights the deeply unsettling relationship we have with our own continuity.
Section 2. The Measurement Problem. To understand how that terrifying glitch actually mirrors reality, we have to shrink down to the quantum realm. So, as a quick refresher on the wave function, we already know that at the quantum level, particles like electrons and photons, they don't behave like solid, predictable little objects. Instead, they exist in this weird state of uncertainty, a superposition. Physicists use a wave function to mathematically describe all the possible ways a particle could behave simultaneously. But remember, it's not a physical wave of energy or water. It's literally a wave of probability.
We've all seen the classic double-slit experiment, right? You fire unobserved particles at a barrier with two slits, and they somehow pass through both at once, creating this beautiful, complex interference pattern. But the real weirdness happens the absolute second you try to observe them. Placing a detector to measure which slit they actually pass through seemingly collapses the wave function. The particles suddenly just act like solid, fixed objects, creating two simple lines. It's like they essentially choose a definitive state just because we were looking.
NA, if your brain is hurting right now and this completely defies your intuition, you are in excellent company. The classical rules of cause and effect just fundamentally break down there. Niels Bohr, literally one of the founding fathers of quantum mechanics, hit the nail on the head when he said, "Those who are not shocked when they first come across quantum theory cannot possibly have understood it."
Section 3. The Everettian Heresy. Enter our protagonist, a brilliant but tragic physicist who decided to challenge the entire scientific establishment. In 1957, a Princeton graduate student named Hugh Everett III proposes a completely mind-bending solution to all this. He basically asked, what if the wave function never actually collapses at all? What if when a measurement happens, reality itself just splits? Under his many worlds interpretation, every single possible outcome of a quantum measurement actually happens. They just happen in separate, non-interacting branches of reality. You aren't forcing the universe to choose, you're just becoming entangled with one specific branch.
So Everett essentially mathematically proves the existence of infinite universes. But ironically, his own life was strikingly finite and, honestly, deeply flawed. After he defended his thesis, he left theoretical physics completely. He went to work for the Pentagon as a defense analyst, calculating the horrifying math of nuclear fallout. The guy drank heavily, smoked 3 packs a day, and ate whatever he wanted. Maybe he was banking on surviving in at least one parallel universe, right? But in ours, he died suddenly of a heart attack in his bed. He was only 51 years old.
And part of the reason he left physics in the first place was the absolutely brutal reception his theory got. When Everett went to Copenhagen in 1959 to share these ideas with Niels Bohr, it was a complete disaster. Bohr's devotees utterly rejected him. Leon Rosenfeld, a really close collaborator of Bohr's, even wrote, He was undescribably stupid and could not understand the simplest things in quantum mechanics. Ouch. It is just deeply painful to realize that this fierce rejection drove such a brilliant mind entirely out of the field.
Section 4. Quantum Russian Roulette.
Because if the many worlds interpretation is actually true, it triggers the ultimate quantum test of survival. To really put this to the test, physicist Max Tegmark popularized this incredibly macabre thought experiment called the quantum machine gun. Let's walk through this. Imagine a lethal weapon tied directly to a quantum measurement. Let's just say it's measuring a particle's spin. If it measures spin down, the gun fires and kills you instantly, literally faster than your brain can even perceive it happening. But if it measures spin up, nothing fires. You just hear an audible click. Now, what's really interesting about this is where we hit absolute certainty. According to Everett's theory, the universe splits every single time that gun makes a measurement, right? So in one universe, you die, but in the other, you live. And because your consciousness cannot experience being dead because death is just oblivion, your subjective stream of consciousness is completely bound to follow the branch where you survive. You will just hear a click. With 100% certainty, some version of you survives.
So the absolutely crucial takeaway here is the staggering difference in probability. To put that into perspective, under classical physics, your chance of surviving 40 consecutive clicks of this machine gun is a dismissive 1 in a trillion. You would almost certainly be dead. But under many worlds, 100% chance of survival. The universe branches infinitely, and you simply ride the wave of the extremely improbable conditions that allow your subjective awareness to continue forever.
Section 5. The Curse of Immortality.
Because, unfortunately, there is a horrifying caveat to living forever in a quantum multiverse. Here's the catch. Quantum immortality only guarantees that some version of your consciousness persists. Sure, it dictates that you're going to evade fatal accidents, the sudden car crashes, the unexpected heart attacks. But it does absolutely nothing to save you from the slow, agonizing realities of aging, failing organs, or a deteriorating mind.
Philosopher David Lewis expanded on this with a genuinely chilling warning. He said, "Eternal life on such terms amounts to a life of eternal torment." I mean, just imagine an infinite existence trapped in a perpetually decaying body. You survive every single moment, but you're accumulating ever more deterioration. You outlive your loved ones, your mobility, your health. You basically become trapped in a state of endless conscious decay.
And the weight of these infinite parallel universes had a very real, very tragic impact on the Everett family itself. Years after Hugh Everett's death, his daughter Elizabeth tragically took her own life. She left a heartbreaking note asking for her ashes to be thrown in the garbage, exactly like her father's were, writing, "Maybe that way I'll end up in the correct parallel universe with Daddy." It violently grounds this highly abstract theoretical physics into the deep emotional weight of human suffering and our desperate, desperate desire for connection.
Section 6. The Illusion of Self.
Because whether quantum mortality is literally true or not, we are forced to ask a deeply destabilizing question. Who are you really? Let's think about the fragmented self for a second. Even if you completely ignore the many worlds theory, you are constantly splitting. Your body today is made of entirely different cells than it was a decade ago. Your memories constantly evolve, they recontour, they fade. And if reality is splitting into countless branches every single second of every day, a continuous singular self might just be a total illusion. You're essentially a clone of the person you were a second ago, inheriting their memories and moving forward into a brand new reality.
So, I'm going to leave you with this final drop-the-mic question to ponder. If you are constantly branching, constantly being replaced by a near-identical clone in a continuously splitting universe, which version of you is the real you? Are you everyone, everywhere, all at once? Or are you just the incredibly improbable version that happened to survive long enough to watch this explainer? Take a second to really think about the infinite paths you are taking right now.